Okay, today we're going to learn about equations with variables on both sides. The objective: I can solve multi-step equations with variables on both sides. Now, here's a quick example of what that looks like. 3x minus 2 equals 6x plus 5. You'll notice I have two variables, 3x and 6x. And again, I have that imaginary line that goes through the middle of my equation. So here's a scenario where I can't combine like terms because one x is on one side of the equation, the other x is on the other. Okay, the steps to solving these type of problems. Step 1, distribute if you see parentheses. Step 2, combine like terms if you can. Again, must be on the same side of the equation. Step 3, this is the new step, we're going to move one of those variables to the other side of the equation. And then the final step is, at this point you should have a two-step equation. Example number 1, 8 minus 3n equals n minus 8. Okay, you'll notice no parentheses, so I can skip distributing, step 1. I'm going to draw this imaginary line through my equation because I really think this helps when it comes to the combining like terms portion. You notice on the left side, 8 minus 3n, not like terms. One has an n, one does not. On the right side of my equation, n minus 8, also not like terms. One has an n, one does not. So therefore I can skip step 2, combining like terms. Let me go ahead and erase that. Alright, we're on to step 3, which is the new step. We are going to move one of these variables. Now, one thing I want you to add is I want you to put a little 1 in front of that n. Again, if you don't know this already, if there's no number in front of the variable, we call that the coefficient, it's always going to be a 1. We just know it exists. Now, if I want to make that 1n disappear and move over to the left side of the equation, okay, the way I make a positive 1n disappear is I subtract 1n, okay, which would basically enhance make a 0, which represents nothingness. Now if I do it on the right side of that imaginary line, I have to do it on the left side. You'll notice how I line it up under the negative 3n because they're like terms. I want to line it up in a column. I wouldn't want it over here underneath the 8 because I couldn't combine those two things. So on the right side, 1n minus 1n would go away. And my new equation would be 8 minus 4n equals negative 8. Negative 3n minus 1 is negative 4n. Now we're down to a two-step equation. Step 1, subtract 8 from both sides. My goal again is to get that n all by itself on the left side of the equation. My new equation is negative 4n equals negative 16. And step 2, divide both sides by negative 4. Your final answer should be n equals 4. Example 2, 8 minus 3k equals 4k minus 6k. Again, I'm going to draw this imaginary line through my equation. Step 1, we can skip, no parentheses. We cannot distribute without parentheses. Step 2, combine like terms. On the left side of the equation, 8 minus 3k are not like terms, cannot combine them. But on the right side of the equation, you'll notice 4k minus 6k. Those are like terms. I can compress those two things and put them together. 4k minus 6k is negative 2k. And I'm just going to drop everything down on the left side. So now I'm down to what looks like to be a two-step equation. But step 3, move one variable. Now you'll notice I've got a negative 3k on the left side and a negative 2k on the right side. Now this is a weird scenario, and I see this happen a lot of times. Often, okay, people want to move this over to the other side, but my goal is to get k's on one side, everything with a k, and numbers without a variable, without the k, on the other side. So it wouldn't make sense for me to move this over here because then I would move more stuff over to one side. I'd have variables with the k and variables without the k on one side. So I'm going to move this negative 3k to the right. The way I make a negative 3k go away on the left side is I add 3k, the opposite operation. If I do it on the left side, I must do it on the right side. My new equation is 8 equals 1k. Now, normally, the next step would be a two-step equation, but this is really nice when it works out like this. I'm basically done. And there's no need for a two or one-step equation because I've reached my goal. I have k all by itself on the right side of the equation, or the left side if I would rather do it that way. My final answer is k equals 8. Example 3, negative 3 times the quantity 2x plus 7 equals negative 3x minus 12. Again, I draw my imaginary line through the equation. I see parentheses, so I'm going to distribute. I like to circle the negative 3 so I don't forget that I'm actually distributing a negative number. I'm very careful when I distribute that I'm multiplying, and be very cautious of your signs. Negative 3 times negative 2x is positive 6x. Negative 3 times 7 is negative 21. So on the left side I have 6x minus 21. On the right side everything drops down. Equals negative 3x minus 12. I have no like terms, so I can skip this step. Next step, I'm going to move one of the variables, and it doesn't matter which one you move. I personally always like to move the smaller variable. I've got a 6x, I got a negative 3x. Negative 3 is smaller than 6. So in order to make that negative 3x go away, I'm going to add 3x to both sides. Disappears on the right. My new equation is 9x minus 21 equals negative 12. And now I have a two-step equation. Step 1 is to add 21 to both sides. I have 9x equals 9. And step 2 is to divide both sides by 9. And my final answer is x equals 1. Example 4. 24 plus 4x equals 6x plus 8 times the quantity 2x minus 6. I draw the imaginary line through my equation. Step 1, I'm going to distribute. I get 8 times 2x is 16x. 8 times negative 6 is negative 48, which gives me 16x minus 48. Everything else drops straight down. Step 2, combine like terms. On the right side of the equation, I've got a 6x and a 16x. Those are like terms. I can put those two things together, which is 22x. The negative 48 drops down. Everything on the left side drops down. Step 3, move one of the variables. My goal is to get all the x's on one side, all the numbers without the x on the other. So I either have to move the 4x or the 22x. And I personally always like to move the smaller one. Again, it does not matter. You can move either or, and you should get the correct answer. So the opposite of adding 4x is subtracting 4x. My new equation is 24 equals 18x minus 48. And now I have a two-step equation. Step 1, add 48 to both sides. I get 18x equals 72. Step 2, divide both sides by 18. And my final answer is x equals 4.